Hello there, I'm Thomas Hatsios. This is the American pilot flying the Boeing 787-900 in the United States. We're going to be overflying Zurich, Switzerland right now, then coming back to the Zurich International Airport where I'm moving for an ILS localizer landing. So right now I'm in the cockpit for the pre-takeoff operation of the quality wings Boeing 787-900 and Microsoft Flight Simulator X. I'm going to start showing you the cockpit instruments, displays, and functions of the Boeing 787-900 aircraft. I'm going to start with the primary flight display that displays the airspeed indicated with the speed selected from the autopilot and flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the barometric pressure of the outside atmosphere, the target altitude selected from the autopilot and flight director system panel, the radio altitude above the ground level, the vertical rate of climb and descent of the aircraft in tens, hundreds, and thousands of feet per minute. That determines also the steepness of the trigonometric angles in decrease can climb and descend. The altitude indicator with the artificial horizon, the pitch altitude, the pitch ladder in degrees, and the bank angle in degrees. The angle of attack of the aircraft as it flies, the ILS localizer, the horizontal localizer, and vertical glide slope of the ILS localizer instrument landing system we have selected for the runway we're going to use for takeoff and for landing. So we have the horizontal vertical guidance for takeoff and landing. Into the runway using the magnetic north pole heading. We're going to use the magnetic north pole heading for the runway alignment. We have also the ILS localizer crossbars for guidance, and the ILS localizer, the frequency and the name. Displayed in the primary flight display, we have the flight director crossbars for manual guidance of the aircraft and the autopilot crossbars for automatic guidance of the aircraft. We have the flight mode annunciator with the autopilot and the auto throttle later and vertical navigation modes, and also the integrated display in the primary flight display that displays also the magnetic compass and the flight plan we have created. So you can see all these things here in the primary flight display. We have the navigation display also that displays the horizontal and vertical profile of the terrain around you from the terrain and weather from the weather radar reflection. You can see the terrain in the horizontal and vertical profile. We have also the flight plan. We have created a route or flight path or flight plan using the flight management computer. You can see the purple line with the name of the waypoints over here. We have to cross, and this is the flight management computer we already used for creating this flight plan. So you can see the horizontal and vertical profile here of the flight when we're going to be flying. You can see other aircraft that fly around you. We have the transponder, the DSP, DC transmitter receiver that transmits our frequency to other aircraft in the air traffic control, and also receives from the other aircraft and displays the other aircraft in a diamond shape with the warnings in the navigation display and the primary flight display of the TICA system, the traffic collision advisory system. You can see the altitude difference of the other aircraft, whether they climb, the descent, and the direction, and calculates also the airspeed. We have the magnetic heading and track the magnetic north pole and true north magnetic variation over around the world. We have, as I told you, we have the terrain map with the airports. You can see the airports where they allocated the runways we're going to use for takeoff and for landing. The runway length, their heading, and also the ILS localizer. We can have the board stations, the ADBs, the NDBs, ADFs, the waypoints, which are horizontal vertical navigation fixes we have to cross through. You can see the waypoints in the navigation display. Also, when we create the flight plan and we select them, so we have already created a flight plan. I put all the data of this flight, for this aircraft, for this flight, from takeoff all the way to climb, cruise, descent, approach, and landing. So we're gonna have the complete flight in the end part of the video. You're gonna see me hand flying the aircraft or using the autopilot and flight director system panel with the auto throttle for a while. So we're gonna have maybe we're gonna have about an hour more for this video. So I'm gonna show you all the data. I input all the data for this flight. That includes the empty weight, the takeoff gross weight. That includes the empty weight plus the passenger plus the cargo. plus the fueling board, where the fuel is stored in the left and the right tank. If it is balanced in the center tank, this calculates the center of gravity of the aircraft for takeoff and for flying, and also the horizontal tail trim stabilizer, using also the main aerodynamic chord position for this calculation, the Mach, which is 23% of the forward wings aerodynamic chord. So this position with the position with the maximum aerodynamic lift occurs in the wings as the aircraft flies is the center of pressure of the calculation from the top surface of the wings, and where the stall of the wings will begin in the top surface of the wings. The airflow will become detached from the top surface of the wings, and the aircraft may gonna start falling. You're gonna see also that we have to avoid the stall speed. It's displayed all the time in the primary flight display with fire. So this is for a given angle of attack and airspeed, the stall speed. So we're gonna have the flight speed also calculated all the time. We select the runway we're gonna use for takeoff. We have the runway, we have the Zurich International Airport Lszh, it's runway 14 right now. We are located here at Zurich, Switzerland. So we're gonna have this runway, the runway length, the runway slope, the wind direction and speed, the runway conditions, if it is ice, dry or wet, the temperature of the air, the pressure and the density. So we're gonna have the takeoff, we're gonna have also the flaps set for takeoff at 15 degrees. So this is gonna set us the takeoff rating for the thrust levers or the speed we're gonna use using the autopilot flight director system panel. So we're gonna set the thrust rating for this takeoff for this V speeds, the V1, V rotate and V2, which is the takeoff flight speed. We're gonna have the complete flight plan or flight path or route of the aircraft, as I told you, using all this data. So I input the seats, which are the other instrument departures, horizontal waypoints and fixes for the initial climb and departure of the aircraft. We have the top of climb, determined waypoints and fixes for the cruise level of the Boeing 787-900 aircraft. You're gonna see also the top of descent. We're gonna initiate the descent of the aircraft, and then we have the stars, the other arrival waypoints and fixes for the terminal arrival to the destination. It's the same airport in this case. So the stars are the horizontal vertical indication fixes for the approach and landing, terminal approach and landing into the runway. We're gonna have also the Lszh localizer tune, as I told you, the instrument landing system, the horizontal localizer for the runway capture, and the glide slope, which is gonna guide us in the vertical profile. So we can have the alignment with the localizer of the magnetic north pole heading of the runway. We're gonna use this, and we're gonna have also the flaps set for landing and the landing speed using the flight management computer automatically again. We're gonna have also to keep the pitch attitude of the aircraft in takeoff and landing, like no more than 10 or 12 degrees. So we will avoid that tail strike. I will show you how to do that. You can see the pitch attitude in the primary flight display when you rotate for takeoff or for landing. Also pay attention to this detail. So we're gonna have also, as I told you, all the data, flight speeds, altitude, vertical rate of climb, descent. So we're gonna have the autopilot and flight director system pilot. So I'm gonna show you all the data now. The flight controls of the aircraft also. You're gonna see how to control the flight controls unit, the side stick. You can see the tail moving here, and the horizontal tail and the vertical tail. So for instance, here we're gonna have the horizontal tail trim stabilizer set for takeoff, the pitch trim calculated automatically using the flight management computer, using the takeoff speeds, the aerodynamic chord position, the center of gravity, as I told you, and the flap settings for takeoff and the runway length. So we're gonna have the pitch trim set automatically, like 4.25 degrees. We have the auto trim system from the autopilot and flight director system panel, which trims the horizontal tail of the aircraft as it flies automatically, so it keeps balance of the aircraft. So we can also trim manually if we need to balance the way we want. So we use this trim switch here the horizontal trim with stabilizer. Oh, you can see here the pitch trim as I apply this. So you can see this is the pitch trim of the aircraft here. We you detail the autopilot disconnect also. We have here um, the alternate. You will see here pitch trim. Over here alternate. We have the parking brakes and the alternate pitch, as you can see, trim. It also reads the elevator trim, left click down, right click down. So we have click down and click up, and it's the same function but the alternate over here. So this trims the horizontal tail of the aircraft here. As you can see, the horizontal tail of the aircraft. We're gonna explain a little bit aerodynamics and flight theory. So you have the elevator for climb and descent, and also you can trim it. You can trim the other surface like the rudder, also in the ailerons and the spoilers in this aircraft. So mainly it's the horizontal tail trim, as you can see. So we're gonna have the explanation for that before flying the aircraft. You can see we have these guarded switches here also. You can see the cutoff, the horizontal trim stabilizer, the cutoff switch. We have the L2 and R2 normal stabilizer. So if we're gonna lose the hydraulic systems here, the L2 or NR2, we're gonna use the alternate pitch string maybe, and the manual only, and we're gonna have to use the cutoff position for that. We're gonna disconnect the autopilot and the auto throttle from the auto trim function. So you're gonna have only manual trim for this horizontal tail over here, as I told you. So you can see also the wings here. As I told you, we have the thrust from the engines, the vectors, the mean aerodynamic chord. We have the forward wings of the aircraft. We can see the surface area of the wings holds the weight of the aircraft as the aircraft flies through using the airflow pressures. So we have the mean aerodynamic chord position about 23% of the Mach, where the maximum aerodynamic lift occurs and where the stall will begin for a given angle of attack. We have the center of gravity position around here, close to the mean aerodynamic chord position, forward or aft. And also we have the longitudinal axis, and we have the vector from the center of gravity all the way back to the horizontal tail for the horizontal trim, stabilizer for the elevator command, also the rudder left and right, and the ailerons and the spoilers. So this is Newton's physics and aeronautical aerospace engineering, and also Bernoulli theory of fluids. So you can see the bottom surface of the wings is more flat, so the airflow as the aircraft flies uh, is moving slower below the wings, so we have higher pressure below the wings. We can use also the flaps to increase the flatness of the bottom surface, and the top surface, you can see it has higher curvature, it's more curved, so the airflow of the air mass is moving faster above the wing and slower below the wing. So we use the flaps for landing and for takeoff in lower speeds to increase the lift. So we have higher pressure below the wings, which pressurize the aircraft wings up into the air, and lower pressure above, which sucks the aircraft up into the air. So this is the aerodynamics. Also the other surfaces have the same principle. The airflow deflections and pressure difference. So I will continue now with the rest of the systems. I will show you the flight controls right now of the aircraft, the engine thrust commands. So we command the engine thrust right here using the thrust levers. You can move forward and aft. Also the flight controls. So moving forward and aft, you will see the engine changes here, the indications. So I will explain in a while. You can see the N1, which is the N1 exhaust gas temperature, and 2 fuel flow, oil pressure, oil temperature, quantity, vibration of the engine. The autopilot and flight director system panel also is here. I will have to make the explanation of the systems. So we'll start maybe with the flight controls right now. This is more I think of importance right now. So save that. And so I need to display a little bit better the display of this function of the flight controls. So you can see me here. So I'm gonna show you how I control the flight controls of the aircraft using the horizontal tail. I will show you the horizontal tail, the elevator for pitching up and pitching down, climb and descend the aircraft, and also the ailerons and spoilers in the left and right wing is the control wheel. So we have the control column in the control wheel in the yoke of the Boeing 787 and 900Z aircraft, so we can bang roll left and right using the control wheel, the ailerons and the spoilers in left and right wing, and climb and descend using pitch up and pitch down the control column. And also we have the rudder pedals for the nose wheel steering in the ground, for the rudder deflection in the air, for young turns, and also for toe brakes in the ground also. So you're gonna see all these the thrust levers and the horizontal trim stabilizer. So I use this Lszh Extreme 3D side stick for this function. So I will show you now. So I'm having here the side stick, as you can see. So you can see we can climb and descend and make turns left and make turns to the right. So you can see all the flight controls now using my side stick, the Lszh Extreme 3D. As I told you, the control the yoke and the rudder pedals of the Boeing 787 and the thrust levers. So I hope you have a better view now. So we can climb, we can descend, we have full control, we can make turns to the right, and also so make turns to the left, make turns right. You can see how fast the deflections are. So you can see the side stick deflection is the same like in the Airbus aircraft. So we can have the rudder pedals and also all the thrust levers here applied. So you can move the thrust levers forward like this, forward enough. So we have the thrust levers function also here, as you can see, alongside with the flight controls like that. So this is climb, descent, make turns left and right, and the rudder pedals, and also the thrust levers, full flight controls of the aircraft. So I'm gonna show you also when flying a little bit the flight controls function. You can see both left and right side, captain and first officer are interconnected, move together in flight. I'm gonna show you also a little bit the outside view using the flight controls using the side stick right now, the Lszh Extreme 3D, so you can keep seeing the same functions using the side stick in the yoke of the Boeing 787 and my side stick. So Uh, so you can see all the deflections again, and here the outside view of using um, perhaps like this, maybe better view. Yes, it's better view like this. It's more lit like this, I believe so. So again, climb, descend using the elevator of the horizontal tail, the column of the yoke, and make turns left, make turns right, and make turns left, using the ailerons and spoilers and the rudder pedals. So also the view outside, you can see all the flight controls. Make turns, climb, and descend. So we're gonna have these now for these functions. So now I'm gonna show you the rest of the aircraft systems. We're gonna make an engine start demonstration, then we're gonna make a complete flight from takeoff, climb, cruise, descent, approach, and landing. You're gonna see the complete flight in the end part of the video. So thank you for staying with me until the end part. I'm Thomas Hatsios again. They're gonna make a power flying the Boeing 787. I'm gonna start showing you the autopilot flight director system panel. We're gonna set the airspeed, the heading, the vertical rate of climb descent of the aircraft for climb descent, and the altitude. We can have the autopilot engage and disengage switch, the flight director engage and disengage switch, the auto throttle engage and disengage, and the thrust levers. So we're gonna select the airspeed guidance of the aircraft. This will command the engine. We have the GNX General Electric turbofan turbines engine installed in our jet aircraft, one left wing, one right wing for symmetrical thrust and redundancy. Each one contains a gearbox with the FADEX. The FADEX are the full authority. These electronic control computers, one installed per engine gearbox, controls, monitors, and displays all the data of the engines as we fly. We have the N1, which is the low speed starter, low pressure compressor and turbine of the turbofan turbine engine. We have the exhaust gas temperature per engine. We have the N2, which is the high-speed starter, the high-pressure compressor, and turbofan turbine engine, the fuel flow pressure per hour, 1,000 kilograms, 1,000 pounds of pressure on temperature, quantity, the vibration of the N2 stage of the engine. We have the outflow pressure. I'm going to show you in the overhead panel the pressurization of the aircraft. You can see the outflow valves from the 5th to the 9th stage that admit outflow air from the bypass or in the stage. So we have bypasser admitted in supplied to the hydraulic fluid tanks. The hydraulic fluid tanks pressurization, which are used for the flight controls, like the ailerons, spoilers, the elevator, the rudder, the thrust reversers, the landing gear and the truck, the parking brakes, and other systems. So we're gonna have all the hydraulic system, the APU. Also, we have hydraulics. We have the wing and engine, the ice, air conditioning, and ventilation, and the cabin pressurization as we climb and descend. So you're gonna see all these outflow air. Also, the FADEX control the fuel flow into the engine, the fuel metering unit, the pressure inside the engines, the outflow valves regulators, the fuel heat exchange sensors, so we can heat the fuel in flight. It won't freeze, it won't get ice cubes in the fuel tanks. So we're gonna have this, and we have also other data, fuel heat, oil heat exchange sensors. We have fuel metering units. Also engine start, engine down, engine failures. As we climb and descend to higher or lower altitudes, as we climb higher and higher, and like 20, 30 or 40,000 feet above the sea level, as we climb higher, the air density, the temperature of the air and the oxygen becomes less than half of the sea level. Also the temperature becomes freezing, like -40, -50, -60 degrees below zero, Celsius below zero. So we have also the airspeed of the aircraft is like 2 or 3 times faster than that of the sea level. So we have higher intake of air from the front fan of the jet engine into the compressor from compression and combustion and air fuel mixture. So we have a different fuel or mixture request every second. This is done automatically using the FAREX again. The N1 limits the rotation of the fans and the starters. So we have all this done automatically. Also, as we descend into lower altitudes, this is done automatically using the FAREX. So it's a good thing to have the FAREX installed into your engines. So when we select the airspeed guidance here in the autopilot flight director system panel, we have automatic thrust selection. The thrust levers will move automatically, not like in the Airbus. In the Boeing we have movement. Also we can disconnect the auto throttle and move the thrust levers on our own manually if we wish. So we're gonna see also that the manual thrust selection over here. I'm gonna show you the flaps, the speed brakes, other functions, the fuel flow. So I will talk to you also the overhead panel, also the electrical, hydraulics, fuel system, and electronic engine control for the engines, primary flight control computers, air data control computer with inertial reference position, flight control surfaces, ram air turbine. I'm gonna have the auto start, the ignition of the engine, and electronic engine control, wing engine ADIs, pressurization and pressurizer to other systems. So you're gonna see all the data. The flight management computer also we set already the flight plan here. You can see the horizontal and vertical profile as I told you, the waypoints we have to grow. So also you know a little bit the autopilot flight director system panel also. Over here we're gonna set the airspeed for the initial climb. We can set also the LNAV and the VNAV if we wish. The bang angle of the aircraft here and the heading. So we set also auto throttle left and right, the director on and off. So we're gonna set the heading over here. For the magnetic North Pole heading of the runway, we're gonna use for takeoff and landing. Vertical speed zeros, we can descend the aircraft, and we can climb the other way, the slider. We can select the altitude. We're gonna cruise initial cruise altitude, then we're gonna fly higher. So we have autopilot engaged, disengage. The autopilot engaged is prohibited below 200 feet. So we have the LNAV and the VNAV again. So we have all the data we need for this flight all set now. For flight, as you can see, we have the electronic flight bag here, the computer. Also, I'm gonna show you another time after maybe flight. So you can see now the airspeed selected with magenta, with purple, is 253 knots, 25,300. The target altitude, the pitch ladder in degrees, the bank angle in degrees, the airspeed indicated, the altitude right now, the vertical rate of climb, descent. You see this needle moving up when you climb, moving down when you descend. So we have to pay attention to pitch altitude, the radio altitude right now above the ground level. This is going to be used for the localizer. We have also the waypoints here, the flight plan. You can see from takeoff also here the terrain around you, and this is the runway we're going to use, the takeoff, climb, then cruise, descent, approach, and landing. You can see the plan over here both ways, and also increase the range. You will see further away the climb over here, and then the descent. I'm gonna start descent. So we have the engines indications. I talked to you about the FAREX. So this is the thrust levers. We have the thrust reverse thrust, auto throttle, disconnect, takeoff, go around also. So now we have the thrust reversers open, reverse thrust. So we disconnect the reverse. So we have the landing gear here up and down, the alternate gear, the lock override, the parking brakes here, the auto brakes, excuse me, for landing and for executive takeoff. The flaps position, the horizontal trim stabilizer, the takeoff gross weight, the fuel on board. So we have the N1, which is low speed cylinders and low pressure compressor, 2 fan to put the engine, the takeoff limit 100.8%, exhaust gas temperature into which is the high speed high pressure compressor and start of the turbofan to put the engine. Fuel flow parents per hour, all 1000 kilograms, all 1000 pounds, oil pressure, oil temperature, quantity, and the vibration being saved on the engine flight management computers, pilot flight director system panel, FS, electronic flight instrument system, head-up display also. So we have also the fuel control, the thrust levers, takeoff ground, auto throttle disconnect. You can see the speed brakes extend and retract. So this extends and retracts the speed brakes like this. So we have the speed brakes. You can see that. We have the flaps here set higher or lower for takeoff. The fuel control left and right engine. The cutout seats, horizontal trim. The fire extinguishers for the left and right engine. The transporter, the rudder trim. So we go now to other systems, like on the overhead panel, just show you everything. So we go in the overhead panel, we have the electrical that I show you, the left and right engine, IDT. The APU, we need to start the APU, so we're gonna have an engine start demonstration. I'm gonna shut down the engine and restart them right now, and then we're gonna have the complete flight from takeoff, climb, cruises, and approach and landing. So stay with me until the end part of the video. You're gonna see all the flight. So the left and right engine IDT, you can disconnect or disconnect the controllers. But to do that in flight, the APU generator, the battery, primary flight control computers, heading reference, inertial reference system, flight control surfaces, the systems, window heat, hydraulics. So we need the APU is gonna provide us with pressurizer for the engine start. For the engine start process, we need to start the APU with a smaller turbine in the tail of the aircraft to start the engines, providing electric for the engine's spark in the fuel system and the fuel burner. So also some pressurizer for starting the rotation of the blades of the fans. So we have the hydraulics here, left and right engine of position. We will see what happens. We have the fault display. Back to the on. So back to the on, also this. So this is the hydraulics, rammer turbine, window heat, the systems, electronic engine control, auto start for the engines here. Fuel jettison, we can dump some fuel, lose weight to make the aircraft lighter. Fuel booster pumps, left and right wing here, tanks, center tank, fuel booster pumps, crossfeed valve and balance between the left and right wing, pressurization of the fuel. You can see when turning on the controller, wing and engine RDIs over here, on and off, and we have the outflow valves, the pressurization. Manual, we use the outflow valves for climb and descent, and use the automatic for automatic pressurization, also bleeder for the air conditioning of the system. We have the lighting system and the windshield wipers also over here. So I'm gonna show you, I'm gonna make an engine start demonstration in a couple of seconds. So another view of the overhead panel here, more detail, better clear view. So we'll go back here and we need to start the engines. We need only one step here to complete. So we have the systems, the display. You can see the hydraulics. You can see all the systems in the overhead panel here in this display in a diagram. So you have the hydraulics, the pressure, in the status. The APU is running 100.8%, the temperature, oil pressure, temperature, oxygen, liquid cooling. So we have the electrical here. You can see the electric, hydraulics, fuel, here. So you can see the fuel, electrics, hydraulics, or are the same diagrams you see over here. Electric, hydraulics, the outflow, the outlay. So fuel system, pressurization. So all these things, you will see them now here in this display from the overhead panel. So we have the electrical left and right IDZ APU is running, load set of the electric power, the voltage of the main battery, and the APU battery, and the average. So we have the controllers, conductors on. We have the hydraulics, left and right engine, 5000 psi, electric C1 and C2, which are air pressurized, sort of valves where the hydraulic fluid goes. Also we have fuel, hydraulic quantity. We have the fuel, left and right wing fuel tank, center tank 11.2 thousand pounds each one, total 33.8 thousand pounds. You can see the low and high pressure fuel valves here are open and feed the left and right engine. You can see the engine symbol from the left and from the center tank or the left and right. The cross-feed valves are closed, but they can, when we open the cross-feed valve, we can feed either engine with either pump or either tank if you have a failure or a leak of fuel. The APU is fed from the left wing using the DC motor. We can also balance the fuel using the cross-feed. The center tank, and also you can see the temperature of the fuel right now is it's plus 4 degrees. The minimum fuel temperature here is minus 37 degrees, so we have to heat the fuel using the recirculation into the engine's heater, fuel heat exchange, so it won't gonna freeze in flight. The air system, the pressurizer, left and right engine, APU, the doors are closed, the cabin can be pressurized, the landing gear, you can see the temperature of the brakes and the pressure of the tires, the flight control system of the, you can see the wings of the aircraft, the horizontal tail and the vertical tail, the rudder trim. So when we move all these flight control surfaces here, both sides you can see are working in the display here. Everything works. So we can also have the horizontal trim automatic, FS display, maintenance systems, circuit breaker systems again, checklist like in the Boeing 777, checklist, normal menu over here. So you use the mouse here, reset, communications. So this is all navigation display. We need to start the engines now. So we're gonna make an engine start demonstration. We're gonna start both engines, fuel control, off position, and you're gonna see both engines off. The N1 exhaust gas temperature all decrease. You can hear the sound of the engine slowing down. This speed brakes are retract from the hydraulics. So we need to turn on over here the restart, the auto start. Actually, you're gonna see some resets in the overhead panel, and here we have the initiation of the pressurization of the engines. Some APU pressurizer is admitted to the engines. You can see the yellows in the overhead panel here because there is a reset right now of the systems, and fuel is still off here. So above 23%, you can see we have enough pressure the right and the left engine from the APU, and we can start the fuel flow process and the ignition of the fuel, turning on the fuel flow, left and right engine. You're gonna see the auto start right now initiating here. So we have the auto start process, auto start, both left and right engine, and as the auto start initiates, we're gonna have the yellow messages here. Some systems are turning on again automatically from the computer. So we have the auto start. You can see the engines here, it's pulling up, have more pressure, and we have both engines right now running, as you can see, running engines automatically. So we set the flaps for takeoff, and we're gonna have the takeoff here. So we're gonna have now the takeoff. Thank you for watching until now. We're gonna start now the flight of the aircraft. We taxi into the runway. Everything is complete, so we advance the thrust levers forward and disconnect the parking brakes and use the tiller, as you can see. Again, thrust to the idle, use the tiller for alignment, some parking brakes, some brakes now we need, and advance the thrust again, parking off. We need to align now with the runway heading, as you can see. So parking brakes again. We're gonna have a sweeter view maybe for takeoff like this. So we're gonna have the takeoff view, advanced takeoff thrust, everything is set, parking brakes off. So we align with the runway center line again, and we have 70 knots. $100 knots. V1, we rotate, rotation speed, speeds up like 10 degrees, no more than 10 degrees, and also speeds up the horizontal trim stabilizer. So we have the initial climb, as you can see. We take off from the airport. Landing gear up here, as you can see. So we have the initial climb here. And we have 5 and 18. You can see the flight directors on the flight plan here. You can see the horizontal, the terrain that I told you, the vertical profile, the terrain below you, the airspeed 170 knots. So we can set also we are 2,400 feet above the ground, 5,000 feet above the sea level. Airspeed, stall speed, vertical rate of climb over here. You can see the climb rate, and the flight plan. So we have all the data we need for flying is okay after takeoff. So we see also the outside view of the aircraft, and we're gonna make a turn now. So we start the turn. And we have 4 and 80, 22 more minutes to fly. So maybe a few less flaps maybe are gonna help us have more airspeed, accumulate more airspeed. You can see we're flying manually here. Hope you like it. Manually hand flying. So we're gonna align here through this waypoint. A beautiful view here again. As you can see, beautiful view. The star sign also. We're flying here, and we have another aircraft flying closer to us, as you can see. Two aircraft actually. Beautiful view. So this is the Switzerland here. You can see the Germany this side, the lakes, the France, and the Zurich. So we have to fly through these waypoints, the intercept, then the Zui. We're gonna be flying through straight, as you can see. So we have the view of the aircraft over here. The Boeing 787. We're flying with almost Mach 0.4 right now. We have the beautiful lakes here. We have the Switzerland, the Germany, the France. So we're gonna have nice views to see here, and also need to follow the flight plan. Over here, 18,000 feet. I'm gonna have the LNAV on. So we have 18 more minutes left for this flight. She's gonna be marginal flying this aircraft in this flight because the video ends on 1 hour 18 minutes. So now we need to align with the flight plan here, this line. Climbing. And 17 more minutes for this flight to end. So we are 31,000 feet, and we have 18 more minutes approximately left. You can follow all the data here. The airspeed, the stall speed 125 knots, as you can see. You can see the trend lights as we climb, and the climb rate 1900. The engine's rating here, and now we have to follow these waypoints as we climb. All the thrust engine. So we have, as you can see, we can, I'm flying manually, as you can see, manual flying. The Lszh aircraft, also the power settings here. So this is hand flying the Lszh aircraft, as you can see. And we have 15 more minutes for this flight. $33,000 feet. You see the head-up display also. All the data. All correct airspeed and altitude and rate of climb. So better view now. Also the lakes here. Beautiful Switzerland lakes here. We're gonna have overflying the Germany, the Bayern Munich, and the France in this side. Very close. The galactic view also. The star signs. And one more of the lake. So we have 14 more minutes left for this flight. Flying manually, as you can see. Let's see the effect. I press up. If I press down, and if I press up, the variation. So initiate the climb again. We passed 35,000 feet over here. So it's 35,036 now, and 37. We're gonna start, and we have ναι.
Αυτή η πετσέτα είναι καθαρή πλημμένη.
Okay, thanks.
Άμα θες να το έχεις.
Okay, thanks.
Πήρα άλλα, οπότε δεν χρησιμοποιούμε. Καθαρό είναι.
Ναι, εντάξει, thanks.
Και σιγά σιγά εγώ θα πηδώ τώρα, ετοιμάσου.
Σε 10 λεπτά θα είμαι έτοιμο.
10...
σε 20 λεπτά.
20 εγώ δεν μπορώ να κάτσω. Εσύ
άμα
θες, ναι.
Okay, thanks.
Κατάλαβες.
Ναι.
Αλλά πρέπει να μαζευτείς.
Okay, thanks. So we keep flying. A beautiful view of the cockpit also. So keep flying manually. We have to take return 37,700, and we have also the chemtrails now. The frozen vapors here. You can see. So we start turn now. Also maybe the airspeed we need to increase a little bit. So this is how to take the turn here. So taking the turn here, finally we have the lakes. So 39,000. We need to actually pitch down here. So you can see we have to follow this flight line here, the line, and also add some airspeed. So pitch up here. Engine thrust, less engine thrust right now. So keep flying manually here, as you can see. So here we are. All our flight data are correct, as you can see. And only need to add some airspeed. The flaps up. And some more airspeed. Really. So keep it level like this, and you can see again the chemtrails from this side. So this is my manual flight right now. The aircraft overflying the lake. Let's see how well level we are. Overflying the France. Over here we left behind the Germany. And we have this beautiful galactic view. 9 more minutes to go to the airport. So we are in the flight plan, as you can see. Using straws, we can use the auto throttle now, because we need to keep flying like this manually. We have 8 more minutes, so we need to also connect the autopilot now. Autopilot engaged, and now we have the autopilot engaged over here, and we keep flying like this, as you can see, having this beautiful view, and the autopilot is connected right now for this flight. So we need also the Lszh autopilot on, and we're gonna have start descent now. Decrease the airspeed a little bit for the descent, and the altitude. Cruise altitude and vertical speed. This is gonna be set for the descent, automatic descent, and we have 6 more minutes left. For this video it went. So we need to decrease this thrust, and the speed works down, as you can see. Keep flying over here by command. Maybe we need we have some overspeed. Keep descending. 6 more minutes for the video to end, and we have over here the calculate just before landing. All set. We need also a little bit more view here. Increase the rings. You can see the terrain, the reflections below you, the altitudes, the waypoints we have to cross. Keep descending. So we have 5 more minutes left to start. Maybe disconnect the pilot. Again flying manually as we release. Four more minutes. $14,000 feet. Keep descending. Keep descending. Making a steep turn now for the landing, and we have 3 more minutes for the video to end. So we're gonna set everything for the landing here. 8,000. 3 more minutes, as you can see. Three more minutes, and some flaps extend. We have the clouds, so we need to pay attention as we descend through the clouds. And some low visibility of the runway, but we are very close. Landing gear down. Airspeed select. And also we have 2 more minutes left. Here we have the runway inside. 2 more minutes. 1 more minute actually. So 1 minute 40 seconds. Keep going here. We're gonna have a nice review here. The touchdown. Hopefully we're gonna make it for the touchdown. before the video ends in a couple of seconds. So we have the Lszh localizer here. You can see the airspeed, all the data. We need full loading where we are located right now. And we are in the side of the runway. We have a few more seconds. Full loading. Fly manually. The video will end at 40 more seconds for the video to end. So here we are, aligned with the runway, some side wing. We need to flare now, so we go about the side wing with cross controls, yoke and rudder pedals. So we have a few more seconds for the touchdown before the video, as you know, will end. So here we touchdown, beautiful touchdown, parking brakes, and thrust reverse, idle thrust, and thrust reverse.